Okay, guys. So lesson 1.5 is solving equations and inequalities by graphing. Now, these are things that, yes, some of you have already looked at the first problem and you've got the answer in your head. That's fine. However, we're going to talk about how we can get an answer to that equation from graphing. Okay, so as I said, a little bit different today. So it says solve it by graphing. Now, notice when we talk about this, this is two pieces equal to each other, right? And what we're looking for is at what value of x does negative 3x plus 20 equal 5? Like, that's the question we have to ask ourselves, is at what x value are those two equal to each other? So in terms of a graph here, what we're going to do is we're going to turn them each into individual pieces. One piece is we're going to look at the left, and we're going to graph negative 3x plus 20. So we're going to graph y equals negative 3x plus 20. And then we're going to look at the other half. What's the other half? The other half is 5. So y equals 5. So what we're doing is we're breaking this apart and looking at it in two pieces. Okay? And I know, in this one, you're looking at like, oh my gosh, this is way more work than what it needs to be done. I get it, but when we get to the end and we don't have an easy way to solve, it actually makes sense to use this method. Okay? So this is kind of the introductory. You're going to be annoyed with me for making you do it the long way. So, okay, so basically, set each half equal to y, right? And we're going to graph them. So, how do we graph y equals negative 3x plus 20? What do you need to think about? What form is this in? Y equals mx plus b. Now, I didn't think about this when I picked this problem. It seemed like a good problem in my head. However, what's the problem we're going to have to mess with here? We're going to have a y-intercept of 20, sorry, and a slope of negative 3 as a fraction is negative 3 over 1. As I said, I didn't think about this, so I was filling out kind of my answer key this morning, and I was like, oh, I really shouldn't have graphed as big of a number as 20. But nice thing is, my graphs go 10 high, yes? So it's easy to scale it and count by twos. Now, I'm going to scale it to the point of, I'm actually going to write it on here, because I'm not in your heads, right? If you don't somehow show me that you are scaling this graph, I don't know that you counted by twos, do I?
Nope.
Okay. And obviously, I know where this graph goes. We'd go negative by twos also. Okay, so we're going to have a y-intercept of 20. There's my y-intercept. In terms of slope, we're going to have to count 3 over 1. Now, I don't feel like we have to scale the horizontal by twos. Are you guys okay if I don't scale the horizontal by twos and we just get to count by ones? I actually think it'll make life easier, believe it or not. So, just so I know, though, I am going to go ahead and say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's just for the reference of when I look at this, I know my vertical is scaled by twos, my horizontal is by ones. Okay? So, when I go down 3 over 1, when I go down 3, each time I count down 1, I'm going down half a box, correct?
Yeah.
And then when I go over 1, though, I'm going over
Half a box. A full box.
a full box, because I didn't scale that way.
Oh.
I don't know, maybe this is a bad idea.
It's okay.
Okay, so here, I'm going to count down 1, 2, 3. I'm in the middle. Whoops. And then I'm about right there in the middle, right? So then if I count down 1, 2, 3 over 1. 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 Okay. Yes, I'm going to be the queen of dots again. However, there's a lot of dots there, and it's necessary that we go pretty much through that first quadrant. Okay? If you're trying to figure out, I did end up with a point at over 6 up one line at 6.2. Did your points end up where my points ended up? As I said, I regret the whole 20 thing, but I can't change it now. So, okay. Now, technically you should connect those points, right? I do have rulers. I have the little, you guys know the little Rose-Hulman rulers?
Yeah.
If you are a straight line person, you want to borrow a ruler. I think I have one here, yeah. There's a little basket of rulers if you're someone that likes to make straight lines and make it neat. I unfortunately can't use that on the BenQ, so I'm going to have to I freehanded. Best I'm gonna get. Okay. You can see the dots, yes? That's the key, right? Because the dots are what are going to help us when we do this next part. How do we graph y equals 5? I'm assuming everyone's still paying attention to me, so how do we graph y equals 5? Horizontal line, yes? Okay. If you want, you can think of it as y equals 0x plus 5, right? It is a y-intercept of 5 and a slope of 0, but I really need you guys getting into it's a horizontal line, yes? So, we're going to go up 5. Now, when I go up 5, that's unfortunate. It's not in the middle, right? Or it's not on a intersection point. It's in between 4 and 6 there. But basically, there's a point all the way across in the middle, yes? And what just so happens if you've done this correctly?
They'll meet.
Do they overlap at a point?
Yep.
They overlap at a point that was on my line. Okay, now, we've done all the work. What is the answer to this problem?
Oh.
What's your guess, Landon?
5.
Okay, now, keep in mind, because he said the right answer, but he actually gave me too much information. Go back to the original problem. Okay? The original problem we were looking at is negative 3x plus 20 equals 5. What do we need to solve for here? Just x. So, x equals 5. In other words, yes, I agree. Not disagreeing at all. Lindy gave me the point where they cross, right? Which typically that's what we think of. We look for the point of intersection. Because they didn't actually give me the two equations. I took one equation and broke it up. Then the answer we're looking for is the x value. Okay? And so in order to answer this, it's at, and I'll write it this time so you have it, at what x coordinate do the lines intersect? And this is true for both, so you can take it all the way across. And in this case, it is, I'm just going to put it up here, x equals 5. Okay? How can we check our answer?
Plug it in.
Can you plug it into the original problem?
Yep.
Negative 3 times 5 is negative 15, plus 20 is 5, 5 equals 5, right?
Yeah. Wow.
Or does it make sense of, okay, I used my old school algebra tools, I subtracted 20 from 5, got negative 15, divide by negative 3, oh hey, guess what? It's 5. Aaron has that look of, really? You just did that.
Why do we have to go?
And again, bear with me. Okay, bear with me. I took a really easy problem and made it really tough, didn't I?
Yeah, no kidding.
Okay. Take a quick peek on the back page.
Better be good.
Can you solve those by hand easily? That's why. Okay, so
You're just sitting.
as I said, we're working our way in gradually. Okay,
Put
so.
your feet in. Hey.
there we go. Okay, now, or even for that matter, is this one easy to solve by hand?
No.
I mean, it's, not as bad as the backside, but this one's not, great by hand. So, what are we going to do? We're going to break this up. Yes?
Mm-hmm.
And one of my equations is going to be what? Y equals absolute value of x minus 4. Okay, we've done a little bit with this. We've done a little bit. What shape is this graph? What shape is it, Aaron?
I walked it.
I heard it somewhere.
There's no line.
It's a V. It's a V. Remember, it's absolute value V. Remember, absolute value V?
Yeah.
Moved where?
I don't know that part.
To the
Right.
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 Moved right 4? Because of those transformations we just quizzed about? Yes? It's in the absolute value, left or right, opposite the sign. This is all coming back to us.
Yes, ma'am.
Okay, so my vertex is normally at 0, 0. We're going to count. 1, 2, 3, 4 right. My new vertex is at 4, 0. What do the sides of my V do if I don't know anything otherwise?
Go up 1 over 1. Up 1 over 1. Up 1 over 1.
Up 1 over 1, yes? So, up 1, over 1. Up 1, over 1. Now, not having my other piece graphed, I'm going to put more dots than I normally would. Because what am I going to be looking for?
Where they intersect.
Where they intersect. And the easiest place to find the intersections is if you have a dot there, right? Because when you use that ruler, do you get a precise line?
Sometimes.
Depends, okay? And so by using the dots, I know for sure where my line is. Okay? So even when I draw a not perfectly straight line here, I'm going to know where that is. Absolute value is a V. Absolute value V, right? If it looks like, I think Aaron said is a line. Well, it looks like it's x minus 4, y equals x minus 4 is a line, but absolute value flips one side up and makes it a V. Now, what's the other piece we're graphing?
Y. 1/2 x plus 1 half.
Okay. Y equals 1/2 x plus 1. What form is this in? Y equals
mx plus b squared.
mx plus b. So we're back to a basic line where b, my y-intercept is 1, and my slope is
1 over 2.
1/2. So y-intercept 1 is right there. Now I'm going to
Rise 1, go over 2.
rise 1, run 2. Can I stop there?
Yeah.
If you only want to get the problem only half right, stop there.
Oh.
The rest of us are going to keep going.
Oh, my bad.
Rise 1, run 2. Why am I telling you we should keep going?
Because they crossed again. They crossed again.
You got a little excited there, but yes, they cross again. Okay? So don't just stop. And you probably, if you draw the line out, you're going to realize, but so we have y-intercept of 1, rise 1, run 2. Gosh darn it.
Why are you so happy?
Okay, we're going to go with it. Do you see why I like to put so many points?
Yeah.
And I can't use a ruler on the BenQ, which is the stinky part, because I need a ruler. It's hard to draw a straight line up here, so. But that's why I put so many points. Because do I have to guess where these are going to cross? No. I can see they cross here at a point that was on my V and my line. And they cross here at a point that was on my V and my line. Now, let's see. What are these ordered pairs?
2, 2.
2, 2.
2, 10, 6. 10, 6.
And 10, 6. What are my solutions?
2. 2, comma, 2, comma, 6. Or 10.
So, x equals 2 and x equals 10. Because there's two answers to this problem. Okay? If we put them back into the graph and check this out, guess what? They're both going to work here. Okay, if you sub them back in, 2 minus 4 is negative 2, but the absolute value of negative 2 is 2.
2, 2.
Half of 2 is 1. 1 plus 1 is 2. So 2 works. If I plug in 10, 10 minus 4 is 6. Absolute value of 6 is 6. Over here, half of 10 is 5. 5 plus 1 is 6. Okay, so both work. So you're looking for those intersection points. Now, did this make a little bit more sense then?
Yeah. Last one is.
Okay. The first one, it kind of seemed like, oh my gosh, this is a waste of time. I can do this in so many easier ways. This one, the graph is actually really helpful.
Yeah.
Okay, it really is. Okay. Now, second section. Now what?
I have no clue.
No, think. So.
We're not talking equals.
We're talking x plus 3 has to be straight.
We're looking at less than, greater than signs.
I was like the same exact thing.
Okay. So, now, here's the deal, guys. We're going to do the same process. Okay. We're going to separate it. We're going to graph them each as lines. There's no shading here or anything. But then after we graph them at lines, we're going to look for when is one line greater than the other line. And I'll explain that when we get there. Sound good?
Yes.
Now, and again, this is one you could solve pretty easily without this method. Yeah, and you can use it as a check. But so first one, I'm going to graph the equation. Y equals what?
We wrote that.
X plus 3.
Yep. 1. 1. She's saying.
Okay. So we're going to graph the line. X plus 3. Focus, gentlemen. Where my slope is the invisible 1. And my y-intercept is 3. So y-intercept 3. What's the slope of 1 look like?
1 over 1.
Rise 1, run 1. Rise 1, run 1. Now, I don't know, how many dots do you want to make? You know, I really did a bunch of dots in the first quadrant. You know, you honestly don't really have to go other than the first, you know. And can you always come back and make more dots later if you need them?
Yes.
Yeah.
You know it.
And again, as long as I have points, I know what my pieces are. Now, what's the other piece I'm going to graph? Y equals 7 minus 3x. How do you feel about 7 minus 3x?
Flip it. I feel good.
If you don't feel good with it, I'm going to put the minus 3x out front as negative 3x. I'm going to put the positive 7 out back as plus 7. That's a personal choice, right? So now, my y-intercept is 7. My slope is -3/1. I'm counting up 7. And then for my slope, I'm going to go down 3/1. If I put a couple other dots just to get my point in the right, or my line in the right spot, down 3/1. You can also go up 3/1 if you need to. But really for me, on my second point, I hit my intersection point, yes? Are we doing okay with the graphing? You're getting lots of review on graphing here, aren't you?
Yes.
So. And, you know, we're starting off chapter 1 with lots of graphing. However, I'm not just throwing you into it and say, there you go, hope you remember how to graph, right? I'm holding your hand, I'm walking you through it, so don't complain. I don't remember how to graph. Okay? I'm reteaching it right now, right? So, now, we have to think this question differently. When the question we are asking is, when is x plus 3 greater than 7 minus 3x? So I'm going to put that in words down here so you know when you look back later what you're asking. When is x plus 3 greater than 7 minus 3x? Oh, I guess I should have put the y equals in there is what I should have done. Whoops. Should say when is y equals x plus 3 and y equals 7 minus x. You know. Now, with that in mind, y equals x plus 3 is my blue line. Y equals 7 minus 3x is my red line. When we're talking about greater than, less than, think about it in terms of when is this one greater than the other? Greater means on the graph, we're talking y values here. When is it higher than? Okay, so when is my blue line higher than my red line?
Wait.
Thoughts on how to answer that? Tate?
X is greater than
Yes.
what?
Now, okay, so where'd the 1 come from? 1 is the intersection point, yes? We still have to know this point. And this point is at 1, 4. Agreed? Okay. Just like earlier, you're still using the x value. What's the x value? 1. So that's why when Tate gave his answer, it involved 1. So now my answer is going to be when x is less than 1, greater than 1, less than or equal to 1, greater than or equal to 1. Those are your choices. Well, when is my blue bigger than my red? Blue is bigger than red to the right of 1, yes?
Yeah.
Over here to the left, blue is lower than red. So blue is smaller than red on the left of 1. And then when they cross through 1, they swapped places. And now my blue line is greater than, it has greater values than my red line. And so because it's to the right of our intersection point, we're going to say x greater than 1.
Because it's going negative.
Okay. I don't know. What? Has my explanation reached you somehow or another?
Has reached you.
No?
Sure.
How else? I'm trying to think, and this is new to, I haven't taught it this way before. So I'm trying to think how else do I want to explain it. Go for it.
How do we tell if you need the little line under your shirt? Or will they never be like that?
Yeah.
Yeah, that's a good
Yeah.
My thought on that one would be,
Good question.
I'm going to be 99% positive here. Okay, I have a slight sliver of I'm not sure. But my thought is, if there's an equal to in the problem,
Oh.
there's going to be an equal to in my answer.
Yeah,
Is that relevant?
That makes it feel.
Like, you basically just have to decide less than or greater than, and then they'll basically tell you if there's an equal to, I think. Now, if you get something wrong on homework, we'll know that I'm wrong there. But that is what makes sense in my brain. Okay, yes.
So what you're saying is just like where it crosses, that's where it is.
Well, where it crosses gives me the value. That tells me to use 1. Now, what we're looking at, this less than, greater than, so I would have said less than 1 if, so kind of think, I'm going to take this off here in a moment, but think about there's being a dividing line, right? That's my dividing line of my graph. And I'm not going to leave that on there, but, so either if we say over here on the left of that line, well, over here on the left of that line, my blue line is below my red line. So that means my blue line is less than my red line. Whereas when I get over here to the right, my blue line is above my red line. So my blue line has greater values than my red line, because we're talking in respect to y values there. Does that help?
Yeah.
Okay. So maybe the visual of the line and like,
So,
So
Okay.
it's not saying that it's greater than as soon as it hits 1. It's saying that it's greater than everything after 1.
after you cross through 1, my values on my blue line are always higher y values than my red line.
You know what I'm saying?
yeah.
Okay? Over here, my blue values were always lower than my red line because my red line is higher on the graph.
So you know if it's the left or right.
What?
By looking.
Well, in this case, the question was greater than. So this case, I was asking, where is my blue line bigger than my red line?
You know what I'm saying?
Okay?
So if,
You were lost too.
so if the sign was the other way, it would have said less than, right?
Yeah, if the sign was the other
It
way.
would have said what is y.
If we had been asking when is x plus 3 less than 7 minus 3x?
Yeah.
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 Okay.
Okay.
You good, Jay?
Okay. Let's try this next one, see if it maybe makes a little more sense.
Yeah.
Yep.
We're going to graph the equation. Negative x plus y equals negative x plus 5. That means there is a slope of
Negative 1 on 1.
negative 1, which as a fraction is negative 1 over 1, and a y-intercept of 5. Y-intercept of 5, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. As long as you have your first quadrant dots, that gives you what you need.
Why?
Who, me? Sorry, I'm really trying to get this, I really want to get this lesson done. I don't want to drag it out. The back two, though, are going to be a little quicker, I think. So, even though they look horrible, they're going to be quicker. Okay, after you graph your first line, you're going to graph the y equals 1/2 x minus 1. That means it's a slope of 1/2, a y-intercept of negative 1. So I'm going to go down 1. I'm going to rise 1, run 2. Rise 1, run 2. Rise 1, run 2. I hit a point in there, didn't I?
Yep.
They should cross at a point. Identify what point they're crossing at.
4.
Okay. The ordered pair is 4, 1, but rightfully so, the number that's going to matter is 4. So, here's what that tells me about my answer. My answer is going to be x. There's going to be a 4, In the middle, we have to decide less than or greater than. Are we okay with that part? This is the easy part, right? Now,
Yeah.
so the question I'm asking, I'm just going to take it right from my question up here. When is y equals negative plus 5? Oh, by the way, guys, I changed it. It was a typo. I caught it this morning after I'd copied them again. What is this sign supposed to be in the problem that I changed? It is a less, I want it to be a less than sign. Original problem change.
I was gonna say.
My apologies.
I was gonna say.
So I know that's going to be thoroughly confusing.
Wait,
I'm
you want
realizing.
it to look like that?
Yes. Change your original problem to be a less than sign.
Oh, alright.
Got it?
Yeah.
You change your problem to match mine. Okay. So when is negative x plus 5? What sign do I have? I have less than y equals 1/2 x minus 1. So if I talk color coding red and blue, I want to know when is my blue less than my red. So it's either to the left of 4 or to the right of 4. So when is my blue line below, right? Says less than. Think when is your blue line below your red line?
To the right. To the right.
Okay. My blue line is below, it's less than my red line after you cross through 4. And so then that means this answer is x greater than 4 because it's after you cross through 4. So in other words, in respect, if I try and get you guys to think about the orange line here again, yes? To the right of 4 is when my blue line has smaller y values than my red line. I'm not sure I've quite sold everybody on that, have
Oh,
I?
you got me. I got it.
I'm trying. Now, okay, do you want the shortcut? I mean, I still want you to be able to graph them, but some of you, if you're concerned about, am I getting the right answer, could you check yourself? Could I add 3x over here and get 4x? Subtract 3 over here and get 4. 4x greater than 4, divide by 4. X greater than 1, does my answer match? Can we go back to our basic solving techniques to check ourselves? You can. Okay. Now, backside. Can we go to the back? Yes.
Where did you put 4 0? Would it be 4 and 1?
That's a 1.
Are you talking about right here? It was the ordered pair 4, 1. You're seeing my parenthesis. My 1 and my parenthesis are going together, I think. Does that make sense? So, well, I was going to say, someone always gets stuck in the back, and Eloise was gracious enough to switch with CJ for me, and maybe that was a bad idea too. I don't know. Okay. Okay. Get your iPads out.
Oh, okay.
Because what's it say to use?
I'll look.
Graphing technology.
Desmos.
You
Desmos.
read my mind.
Oh, I do. I was gonna say
Desmos.
Okay. Grab Desmos.
iPad.
Now, as you go to Desmos, what are the equations you're going to be typing in, do you think?
Those are good.
We're going to graph y equals negative x squared plus 8x minus 13. And then you're going to graph y equals absolute value of x minus 4. And then what are you going to look for? where they cross. Okay, now I am going to try here. If I go over to Desmos on here, will I lose my recording? I don't know. So, remember you can just go into Graphing Calculator, go into Math Tools. Type in y equals, where's my negative? Do I have a separate negative sign on here?
No.
Okay, thank you. Negative x squared plus 8x minus 13. Enter. Your parabola look like my parabola. Then I'm going to go to my next line and I'm going to type in y equals, absolute value is right over here. Right here. You type that, oh, what happened to my equal sign?
Oh, I put -1.
Okay, so absolute value, right here above your ABC symbol. There's your absolute value bar. And then x minus 4. Okay, mine is not,
You gotta press inside. That little press.
and I must not have been inside and didn't realize it.
School.
Sorry, this is hard doing this on the big screen. Okay, absolute value. It has me in there, x minus 4. There we go. Okay, guys, here's the deal. Desmos makes it easy. Are these whole number answers?
Nope.
No.
No. But if you tap, it'll show you the ordered pair.
So that's my answer. Okay.
So what are my answers based on this?
2.6. 697.
Okay, if the directions on the paper say round to the nearest tenth, so this rounds to approximately 2.7, and this rounds to approximately
5.3.
5.3. Okay, so that's in Desmos that I did that. Now, why do I have the graph on here? Just so you can sketch it out. But I know my answers are going to be x is approximately 2.7 and 5.3. You have 15 problems in homework tonight. I would venture to say a little over half of them
Use Desmos.
are using, or around half of them are using Desmos. It says either use graphing technology or there's another way they put it. And it was weird, but graphing technology, it wasn't graphing technology, it was graphing,
It's right. Don't worry about
I don't remember, but
Tool.
it wasn't tools. That would make it too easy, but
Cellular device.
Nope.
Yeah.
okay. So on here, I mean, I put the graph here so we could have something to, you know, draw. But really, it's all about using the Desmos, yes?
Wow.
Okay. Now, I'm out of time. That was quick on Desmos, wasn't it?
Yeah.
Yeah.
However, are you confident with Desmos?
Yeah.
It's the same thing we've been doing all period, yes?
Yeah.
Except you got to use Desmos. Okay? I feel like I actually feel like the homework's going to be relatively easy. I think. I don't know. I could be lying here. I'm not trying to, but you got Desmos on a big portion. Some of them they'll give you graphs and ask you to pick which graph is the correct one. Okay? So give them a try. Homework's due tomorrow.
And what's
Okay.
your speech going to be about?
And I will not plan on coming back to this last problem.
And what's your
Okay.
speech about?
I can put the answers up here in case you are curious where you end up. Because some people care.
I'm sure you used them, but like creative.
Yeah, mine's going to be how to draw homework.
Okay, just a second here.
Mine's how to fold clothes for a trip.
For a trip?
Yeah.
What?
Like I only roll right clothes.